is to take the clue from nature. Nature used two photosystems hooked together electrically in series, each one of which only gives you half the voltage needed to make chemical fuel, but stringing them together at no loss of efficiency in order to get the full voltage that you need from two materials that by themselves were not themselves individually adequate. One drives water oxidation, one drives water reduction. The other advantage of doing this is this material that drives the reduced forms of the cell takes electrons in photosystem 1 and reduces NAD to NADH. Doesn't have to be oxidatively stable. In fact, nature's enzymes are not oxidatively stable. They're driving reductions. They never see the oxygen part. Photosystem 2 does that. It oxidizes water to oxygen. It's not reductively stable. It doesn't have to be. It never sees across the membrane the reductive part. And of course, you need the membrane not only to neutralize the pH gradient, but you don't want to make high-energy fuel like hydrogen and oxygen in the same place at the same time for obvious reasons. And nature has the same problem with sugar and oxygen. It'll burn if it doesn't separate them. So our job is to do what nature did, which is develop a membrane with two photosystems, one that reduces something from water and or CO2, the other that oxidizes water to oxygen. We vent the water, we keep the fuel. It looks like bubble wrap. No wires, no bugs. In goes water and sunlight, and out comes fuel. Okay, that would be a neat trick, because we would solve the storage problem that otherwise you don't solve with solar electricity. We know the components of this have to have a membrane. We know we need catalysts because it takes two electrons to take two protons and make one molecule of H2. And because the solar photons are uncorrelated, those electrons will wander around independently unless we couple them to a catalyst in order to make and break chemical bonds. There are only a few challenges. One is that we know they're a good catalyst to reduce water to hydrogen. It's just that they're really expensive, like platinum or palladium or iridium. So we need to find cheap catalysts, which we think we can do. The other is that we can't use these really expensive materials. The same cost per watt trade holds here as it does always hold. And we have to get the voltage needed to drive this chemical reaction, or we get nothing. So what in the world makes us think we can do that? Well, we actually have an idea that is really reduced to practice. The idea is